So we'll start with the basic idea of what limits and continuity of function. I think so we have done this in the demo lecture, trial lecture,
Yeah, I think so.
that one step forward, one step backward, and all that we have done, correct?
Yeah.
Do you remember anything?
Yeah.
Okay. So now we will be seeing the basic definitions of what limits are and going on some higher levels on what no limits explain us. Let me just give you a brief of what I have sent the syllabus with you earlier
Okay.
that lecture. Have you received that syllabus?
No.
No, I told that I'll send to Jayan sir.
My dad probably has it then.
Okay. So as you can see, no, calculus is basically divided into 2 to 3 parts. First is differential calculus. Second is integral calculus. And the third one is no differential equations. So this is sharing 35% of the total syllabus. This is, I think so, this is also 45%, and this is the rest 20%.
Yeah.
So for advanced engineering and all, after this, if you are trying to go in that line or a computer line, the differential equations are very important. They are the ones we are solving in order to get that solution for day-to-day life problems. So this is a regular application. They have a regular application. Differential and integral calculus are having limited applications. Yeah, they are having limited. Yeah. So let's start with what limit is. Okay, so do you know anything basics about what limit is? What limits are?
It's like where x approaches infinity.
No, 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 no. Not like that. Uh, uh, what exactly you mean with limit? Not with infinity or anything.
Like where the x, the highest or the lowest value x can be.
The highest or the lowest value are basically the maximum or a minimum of a function.
Oh, okay.
So that is a different concept. That is
Mhm.
application of derivative part. No, we will learn that afterwards. In the differential calculus, the ending topics are this maximum and minimum of a function. So what limit is and what continuity is? So continuity, that for any function, it must have a symmetric graph
Yeah.
or vertical line test we are doing. If you are getting anything, you just tell me, or if you don't know, we'll start with very basic.
Yeah.
Okay. So first I'm writing the mathematical expression for what limit is. So we are expressing limit as limit x tends to a for function f of x. This line means that for my function, no, if you I think so, function, what is a function?
Yeah.
No,
It's
if
like
you are
a relationship
facing in,
between x and y.
sorry,
A relationship between x and y.
the relationship between x and y, we are taking y is equals to f of x
Yeah.
is equals to some no quadratic, cubic, quartic, any equation like x square plus 4x plus 9x cube and all. So consider this is my function, correct?
Yeah.
Now when I'm having this thing written down, I'm highlighting this one. This is known as a limit operator. Limit operator. So limit word is basically nearest to, nearing to. going near to, or we can say that tends to. Both word means the same. So what limit operator? Also word operator, I think so you have listened for the first time. So operator is anything which operates on a function, which operates on a function to give some result. So when I say that, no, limit x tends to a, no, this arrow means, this can be written as x tends to a. So consider in this simple case, I am writing x tends to 5. Means x can be 4.999999999. X cannot be 5. If x is 5, I'll write x is equal to 5. No, so these are mathematical expressions. So for x tending to 5, I can write like this. Also for x tending to 5, I can write like 5.0000 dot 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 dot, and at end I'll write 1. So this is slightly less than 5. This is slightly greater than 5. But this is not equals to 5. Okay?
Yep.
Yeah. So what limit operators does is, for this case, I'm applying limit that my x tending to a, means x would be nearly to equals to a, correct?
Yeah.
But I don't care of this assumption like it is 4.9999 or 5.000001. I simply take for the sake of problem solving, what I do, I simply substitute whensoever I saw x a. So I can write limit x tends to a for f of x is simply f of a. This is what basically limit operator does. So if on a function I'm applying a limit operator, so this can just substitute a whensoever I am saying I am having the x part, correct?
Yeah.
Okay. Now there is something, which we are interested in, that where limits are and when limits are not. So where limits are and do not exist. So there are certain points or certain functions for which limit does not exist. So let me take a very basic and a simple case. Suppose I'm having a function f of x is equals to 1 over 1 minus x square. Simple.
Yeah.
Now what I'm doing is I'm applying a limit operator and I'm saying that limit x tends to 1. Now can you solve for me what actually you will be doing for this f of x? Whenever you see x, you just put 1. So here
Yeah.
it is x square. So what I'll do, I'll just put 1, correct?
Yeah.
So I can write limit x tends to 1 for f of x. I can write 1 over 1 minus 1. Okay, 1 minus 1 is 0. So I can write 1 over 0. So what do you think? This is an acceptable form or not?
No, it's undefined.
Okay, so can you say me why it is not an acceptable form?
Because 1 can't be divided by 0.
I cannot hear you. Can you speak somewhat louder?
Because 1 can't be divided by 0.
1 can't be divided by, instead any number cannot be divided by 0.
Yeah.
So the problem is that 0 is in the denominator.
Yeah.
So for sake of simplicity, what we just assume is that any number divided by 0 is tending to infinity.
Mm-hmm.
So in this calculus case, what we can say is that if 0 is in determinant, 0 is in denominator, this cannot be a case, can't be possible. So if this cannot be possible or can't be possible, I can say that limit does not exist. I'm writing this D and E does not exist. So in short form, we can write less. So limit does not exist for x tending to 1. Getting the things?
Yeah.
So whensoever I am having this inappropriate type forms, no, the limit does not exist. So if we solve, no, if we try to solve also for 1 over 0, we are getting infinity, correct?
Yeah.
Suppose if I am having a negative of infinity as my answer, no, you simply take a function like it is minus 1 over 1 minus 1. So it would be a negative 1 over 0. A negative 1 over 0 is a negative infinity. Positive 1 over 0 is a positive infinity. Clear? So in this both the cases, 0 is in denominator. So whensoever 0 is in denominator, the limit does not exist. The case of limit fails. So what we are going to do is, just I am giving you a simple question. You just try in your notebook and give me what actually the limit is at that point. So the question is f of x. I am given something and I want to evaluate the limit at x tending to 1. So easy one.
Yeah.
Yeah. What you get is
3.
3. So for limit x tending to 1, no, you can write f of x is equals to 3. So this is the final expression of what we can write for our answer. Okay.
Yeah.
Solve for this also.
Yeah.
So what you are getting is limit x tends to 3, f of x is equals to
7.
7. Absolutely correct. So I think so this is clear. This part is clear.
Yeah.
Now consider in this question only, I am just changing some things. Like instead of x minus 2, I am having x minus 3. Then what would happen?
It was, wait, 1 second. Maybe 1.
That would be,
Oh, wait. Oh. Oh, 1 second. No, it would be infinity.
it would be, sorry,
Infinity. Infinity?
infinity. So what I can say about my limit is limit does not exist.
Yeah.
So our answer would be limit does not exist. So
Okay.
we can write infinity instead of 1 over 0 or any number over 0.
Yeah.
But yeah, so limit is a case where we need to check whether it is working or not. So in this case, it is not working. So we can simply write limit does not exist.